Hey, hello, what's up? Hi, how you doing? Sawbona, Kunjan, Mambo. Let's get started. So we have a question. Determine the following, simplify the answer. I'm Hamish, right? If possible, my name is Hamish. If you face something right before you get started, come right here, subscribe if you face to my channel. Let's get started. First question, they say simplify. So what we're going to do here, first and foremost, you have to know. This is a product rule. You have this group and this group is a product rule. So we know product rule. The first one, product rule. If I have an f times g, they say differentiate, you can put either, for example, if I start to put this constant, the second one you must differentiate, and then we plus, now the second one is going to be constant, and then we differentiate the first one. That's a product rule. So now we do the same here, right? So now we're going to say simplify. So now you come here, you differentiate y, you're going to get dy equal. Now you come here, since this is a product rule, means I'm going to put the first one constant, and then I have to differentiate the second one. What is the second one? Sinh. And then we plus. Now the first one must be constant. The first one was constant. Now the second one is going to be constant. Sinh of x. Now we're going to differentiate the first one. So say differentiate the first one, cos of x. Okay, so now we go. So dy dx, excuse me, dy dx, because you differentiate y and x, dy dx. Now we go. So for that case now we say, okay, so I have to know how to differentiate sine, sinh, inverse. So this is called sinh inverse, or sometimes they call arc-sinh. Arc-sinh. Okay, now let me show you quick how to differentiate sinh first, aside apart from if somebody say, they give, let's say, y equal to sinh inverse of f of x. When you differentiate this, you get dy dx. You know why? Because look, this is why you get dy equal. Now, when you differentiate sinh, this is what you do. Take this, find the derivative. So you write derivative here on top. You know what I'm saying? And then you say square root, take 1 plus, take this function square. So, and here you differentiate x, because these are x, these are y. Means here you're going to have a dx divided by dx divided by dx. That's how we get dy dx. And that's why we don't write this, because dx over dx equal to 1. You know what I'm saying? So these are rules of sinh derivative. For example, if somebody give, let's say for example, y equal to sinh inverse of x 2x power cube. They say differentiate. So what I'm going to do, I know I have to find the derivative of the function, means whatever is in here. Let's derivate. When you derivate, it's going to be 6 power 6, because 3 times 2 equal to 6, and then x 3 minus 1 equal to 2. So we're going to write on top the derivative, which is going to be 6x squared, and then we're going to write square root 1 is 1 plus f of x squared. What is f of x squared? Means take this square, which is going to give us 4x power 6. You know what I'm saying? So this is dy dx of sinh. You know what I'm saying? So now for this case here, it's easy. So I'm going to say now, I'm going to erase this because I don't need this. So this one we're going to say equal to, we have a cos of x. Now we're going to have to find the derivative of x. When you derivate x, what you get? You get 1, and then you say square root. Okay, square root, and then you say 1 plus, mean this one is even right for you. 1 plus square of the function, whatever is in here, square, which is going to give us x square. Oh, so now we plus, now we come. Sinh is constant. I'm going to write my sinh of x, or sometimes we call arc-sinh. And then when you differentiate cos, you get sinh. This is not inverse, it's just normal cos. When you differentiate cos, you get sinh. When you differentiate sinh, you get cos. Okay, so this is dy dx. So I can put together if I want, but I'm done. Means I can take this one before. I like to write whatever I had before sinh. So I'm going to have a 1 plus x squared cos x plus, I'll write this before if I want. It's not inside bar. I can write like this, sinh, and then I can say sinh. So this is dy dx. You know what I'm saying? So yeah, now let's go to the question number 2. Question number 2 is very easy. So question number 2 is not product rule, it's just a normal, okay, excuse me, normal differentiation. If somebody give you, for example, y equal to cos of any function, let's say g of x. So you see, this is not inverse, like normal. So we say, oh, let's derive now. So this is going to be dy, because we differentiate y, here is x, means we're going to get dx. What you do, if you differentiate whatever is in here, differentiate and then write prime before cos. So when you differentiate cos of g of x, you get g prime of x. And now you come, when you differentiate cos, what do you get? You get sinh. So here you're going to write sinh of whatever is in here. That's what you do. You know what I'm saying? That's going to be any derivative. This is not, you know what I'm saying? Any derivative. It could be tangent. It could be, you know what I'm saying? For example, somebody says y equal to sinh of f of x. Now let's differentiate. So this is going to give us dy dx, because y and x, dy dx equal to, when you derivate this, you get f prime. You write behind. And when you derivate sinh, you get cos of whatever is in here, f of x. For this, for now. So now we're going to do the same game here. You know what I'm saying? We're going to do the same game for this question here. With that game we want to do, please show me. I'll show you now. I'm going to show you right now. Show me, please. Yeah, I'm showing you right now. Right now, show me. Okay, so 1.2, they say, they give you y equal to cos, and then sinh x. So what I'm going to do, I know this is like f of x here. Whatever is in front of the cos is f of x. So I'm going to say, oh, I'm going to say dy dx, because it's y and x, equal, I have to differentiate whatever is in here, and then it must come behind. Means I will say dx of whatever. This is like a function. You know what I'm saying? So it's like, oh, derivate this is going to give you f inverse. And then when you differentiate cos of function, if let's say this is a function, it is a function. It's like cos of f of x, means derivate right behind, and then when you differentiate cos, you get sinh of whatever which is in here. But sinh. Now I'm saying, so we need to get f prime. That's what I say, differentiate whatever is in here. So it's a ddx of sinh. And then when you differentiate cos, you get sinh of exactly. You know what I'm saying? So now let's go. When you differentiate sinh, we know. We just did it now. So I'll take this, find the f prime, means it's like now we're dealing with this only, differentiate this. So we know when you differentiate sinh, like this going to be, differentiate that is going to give you 1, and there we go. Square root sinh inverse, or sometimes called arcsine, means when you derivate x, you get 1, because you know it has to be like this. You know what I'm saying? When you derivate that, okay, what is f prime? 1, when you derivate x, you get 1 plus f square. Fx square means x square, because that x and then you square. Oh, so this is going to be the answer of this. So this is going to be 1 over 1 plus x square, square root. And then now it comes sinh, and then sinh of x. You know what I'm saying? So I can just pull this side. dy dx equal to sinh of x. Because 1 times anything is 1. 1 times 1 orange, 1 orange. Now let's go to question number 3. Question number 3 is very, very easy. You know what I'm saying? So you can make use of these also, just in case in the future you want to use them. I just wrote them to help you, but some of them they have nothing to do with this question here. But it's like you can use those as the tools. Okay, cool. Now let's go. Number 3. Okay. So you got sinh sine of y equal to x e y. So now I'm gonna start on the left, you know, and then I'll go to on the line, on the right, explicit function. Now we go. When you differentiate sine, you get cos. So when on the left, when you differentiate, I get cos. Cos of y. Okay? But since you differentiate y here, I'm going to say it has to do with y. So I'm going to say this is like dy with respect to dx. Oh, let me do this the easy way. Okay, another way you can do. You can say, okay, apply d dx throughout. Okay, d dx of this also. You know what I'm saying? Now we go. When you differentiate cos of y, what you're going to get? Sine, negative sine of y. But what did you differentiate? Y. You see, dy is the one you differentiate. So it means you must give respect dy. And then under here we have a dx. Now we come here. So here, this is a product rule. You deal with the two things here. So I'll say, okay. So I can just write here. So I can set a space. I can say first one constant because of product. And then we differentiate the second one, which is ey with plus now this constant. And then now we differentiate the x. Okay, so now let me go. X is just x. When you differentiate ey, you get ey. You know what I'm saying? You get ey. So this is going to be ey. And then plus, now we come here. Ey is constant. Okay? Oh, excuse me. Just a minute, sorry. X is constant, differentiate ey, you get ey, but you differentiated y. So you must say dy over dx, because there's a dx. Now we plus here. Look, ey is just constant, but now we differentiate x. When you differentiate the x, you get 1. But what did you differentiate is x, so it's going to be dx. But over dx. So this and this is going to give you 1. So it's like it doesn't exist there. Okay, so now what I'm going to do, I want to make dy subject. So what happened? I can either take this one here, so it's going to be negative sign dy dx, or I can take dy dx out because dy dx and this is going to come here. So it's going to be negative sign and then minus x ey, but both of them, they have a dy dx. See, dy dx is going to come out here. So dy dx. Now we come here, it's just ey because dx dx equal to 1 ey. Okay, cool. So I want to make dy dx subjects because I want to get dy. Okay, divide by this. So divide here by negative sign, y, negative x, ey. So I'm going to say, oh, divide the same thing here. I can actually take negative out. So it's going to be sine of y plus x, e, y. Okay, you know what I'm saying? And this cancel. So dy dx equal to ey negative sine y plus x, e, y. Let's go to the next one, the last one actually, it's not next one, last one. So this dy dx means the phase derivative. Let's go for the last one. So you can use this. Okay, so I just forgot something here. In a question they say here, use logarithm, use logarithmic differentiation. Use logarithmic differentiation. Logarithmic differentiation. So they recommend, like, you should do that. Okay, cool. Now let's go. So now what we're going to do here, if they say use logarithm function, means I'm going to apply ln throughout. I'm going to apply ln here on the left, ln of whatever is here equal to ln of whatever is on the right hand side. So what is on the right hand side? Means square root of x squared minus 1 power 5, and then all this over cos of x. So we have a rules in ln. If somebody gives ln of a times b, this may say ln of the first one if there's a multiplication. Then if it's multiplication, you plus here. Say ln of the first one plus ln of the second one. But if it's division, you say ln of the first one and then you minus ln of the second one. So these, you know what I'm saying? These are rules of the ln. But don't ever, if they give, let's say, ln of a plus b, don't ever say, let me say, this is not equal to ln of a plus ln of b. Is not equal. only if it's multiplication. So there's no such a rule. No, there's such a rule. There's no something like this. You know what I'm saying? So now, okay, so in another thing, if somebody give, let's say, ln of a or k, means a can be any number, let's say x power n. You could take n behind, you say n, go to front, ln of x. Also, these are some of the rules, but this is not. Never say this equal to this. No, it's not. When it's multiplication, you can plus. So now we're going to do the same thing here. Let's go now. Let's see how we can break this. So we're going to use these rules of the ln and simplify this stuff. Okay, cool. So I'm going to apply ln already. So ln, when you differentiate ln, if somebody says ln of f of x, let's say this is when you want to differentiate. When you differentiate this, you get f prime, means differentiate f prime and then write whatever is in here. Differentiate this right on top and then write whatever is there. So we're going to say now, another rule, if somebody give ln of f of x, let's say x power n, we can take n back, we say n ln of x. You know what I'm saying? So now let's go. So first and foremost, I have to separate before I differentiate. So this is going to be ln of y equal, remember there's a multiplication here, over. So ln of the top one, which is going to be square root of x, and then plus, why we plus? Because of multiplication, ln of x squared minus 1 power 5. Since this is square root, I can say this is a half, because I know I'm going to do something to the back. You know what I'm saying? Minus, why do we minus? Because there's a division here, so it's going to be ln of cos of x. So after that, you know, I can take a half back before I start to differentiate, take those numbers to the back. So ln of y equal to a half ln of x plus 5, mean this to the back. This row here, x squared minus 1 minus this, nothing we can take to the back. So now we can differentiate when everything to the back, okay, or to the front. Some people say back, sometimes say front. So however you prefer. Now let's go. So when you differentiate this, remember, look, when you differentiate, let's say ln of g of x. Somebody say differentiate this. So this become, so this will happen. Take whatever is in here, differentiate, which is going to give a g prime for this case, and then over whatever you have there. So now we're going to do the same thing. So when I differentiate, because it's going to be dy dx, dy dx, dy dx for each one. So when you differentiate this, it's going to give me, when you differentiate y, you get 1. But over whatever we have here is y. But what did you differentiate? We differentiate y. You know what I'm saying? We differentiate y. So I'm going to say dy, d, just a dy. Or if you don't want to do that, you can just say like this. Excuse me. Say d dx of ln of y equal, a half is just a constant number, d dx of ln of x. Probably this can make you laugh easy. 5d dx of ln x squared minus 1 minus d dx cos of x. My apologies. Okay. So now we go. When you differentiate y, you get 1 over whatever we have there is y. You know what I'm saying? But d, we differentiate y here, so it means this can be dy, but still we have a dx as the denominator. Now we come in half is a half. When you differentiate ln of x, what happened? Differentiate whatever we have here, you get 1 over what we have. But we differentiate what? X, so it's going to be dx over dx. Dx over dx equal to 1. So I don't have to write, but I can just write for fun. But there's no need for me to write for here. You know what I'm saying? Now we go plus. Now this is 5. This is x. So we differentiate whatever we have here. When you differentiate, you get 2x. When you differentiate 1, you get 0. So it's going to be 2x. So the top one is going to be bracket 2x and then over x squared minus 1. And then we minus. Now we come here. When you differentiate cos, you get negative sign. So you get negative sign x over whatever you have here, which is cos of x. You know what I'm saying? So now we go. So now 1 over y, okay, this is going to be, okay, this is going to be 1 over y, okay, dy dx 1 over y, okay, 1 over y for now. We're going to substitute that. 1 times 1 is 1 over 2x plus this is going to be 10x over x squared minus 1, and then this plus sine of a cos equal to tan of x. Okay, so we want to get dy dx. How are we going to get dy dx? Multiply by y multiplied by y throughout. So this and this cancel, so we have a dy dx equal to a half x plus 10 x squared minus 1 plus tan of x. But we know the meaning of y. What is y? Y equal to this. So I want to take this stuff and substitute there. It means because everything must be in terms of x. So now I'm going to say, like I say, this is very, very important for your future uses, okay? So make sure you use this. So we're going to say multiply by square root of x. Instead of write y, I say y equal to the square root of x squared minus 1 power 5 over cos of x. We're done. Okay? So if you FaceTime, man, make sure you subscribe here and share to a lot of people. Easy, man, easy.